Ladies and gentlemen, welcome to our regular series of Connection Wednesdays for IDEA StatiCa Connection. Today, we will show you how to connect finite element and CAD models into one, and finally to get a check of such complex joint. My name is Alexander Szatkowski, and I will go along this webinar together with my colleague Wojciech.
And we are both product engineers in IDEA StatiCa company.
For the beginning, you are all muted by default, but if you have any questions, it's not a problem. You can write them in the questions panel anytime during the webinar. So our main topic in this webinar are BIM links. We will show you a way how to join an analytical and CAD model into one. My colleague Wid, as a designer, will, from his CAD model made in advanced steel, export a joint. He will use our web viewer, which can be found on our main web page. Finally, he sends it to me as a structural designer to do the check. After that, I will also export the same joint into IDEA StatiCa Connection, but from the analytical model. This file I can then easily merge with the file from the designer and make the final check. And if necessary, I will send it back to the designer to make the appropriate changes in the model. This was the first part we will go through. And in the second part, we will talk a little bit about local deformation check and general geometrical nonlinear analysis in our software. For hollow cross sections, especially for hollow cross sections. Now I give floor to my colleague Wid. He is the one who will show you the export of the joint from a CAD model using advanced steel.
Thank you, Alexander, for the introduction. And I will start in a few seconds. As a designer in my company, my job is to create a structural model with all members, with plates, with bolts, with welds, because we need to create or to produce the drawings, the blueprints, is a part of our job. And I did this job with this structure as I'm used to it. I created the main beams, diagonals, and other detailings. But now I need a permission from my structural engineer. He needs to do the code checks of the joint of the whole structure. And I can use my structural model because I can export him the model. Because I don't have the valid license of IDEA StatiCa software on my personal computer, I cannot do it in a usual way with the BIM link, but I can use IDEA StatiCa plugin for the viewer. In downloads, in IDEA StatiCa web page, here we have IDEA StatiCa plugins, and one entry is Viewer plugin for Autodesk Advanced Steel. This viewer is a plugin for Advanced Steel which will enables you export to IDEA StatiCa Cloud Solution Viewer, and it's for free, and you can use it without the valid license of IDEA StatiCa software. I previously downloaded and installed it, and after the installation, in Advanced Steel, I have new sets of commands. If I type in con export, Advanced Steel is giving me a hint with these commands. I can export it to Eurocode, to Australian code, to Russian, American, Canadian, and China code. And right now, I can use these commands to export my connection. Just let me change the view in a way that I'm able to use all features. Now I will type again export, export, and I want to export it to Eurocode. So right now, in the first step, I will choose the connection point, which is the intersection of my member axes. Great. In this step, I will choose all members, and the first chosen member will be the bearing one. Right? And in the last step, I will choose all other entities like bolts, welds, plates, etc. Fair enough. In a few seconds, a progress window for communication with the cloud server appears. Because the IDEA StatiCa viewer is a cloud solution. And in a few seconds, IDEA StatiCa viewer window appears in the web browser. Great, we have our model in IDEA StatiCa viewer, and I can explore the model. I can rotate it, play with it. I can even choose the entities because I'm curious about their properties. If I click on the member, I can see that the cross-section is 160. The material is here. I can click even on the plates and I get the similar information. The material, the thickness, and even some basic drawings. I can get the same info about the welds and bolts. Or I can find it here at the tree of the entities. I can find the weld, click on it, or a bolt grid and explore its parameters. For example, this weld, number 16, has a thickness 4 millimeters and is located here, the gusset plate and the main member. IDEA StatiCa viewer has another really nice features. If you click on the project tab, here we have 3D DVG download. You can download this model in 3D DVG file. And one of the most great one is the IDEA StatiCa Connection file download. So if I will choose it, the cloud viewer sends me IDEA StatiCa Connection project file, which is great because now I can send simple email to my structural engineer Alex and ask him for the code check. I will attach the project file, downloads, project, and the project file is going to my buddy Alexander. Right now I'm passing words to Alexander, to structural engineer.
So thank you, Vít. But before I start with the file from Vít, I first take the analytical model made in FEM and will export the same joint to IDEA StatiCa Connection. This structure was already computed, so all I have to do to click on the add-ons module, IDEA Connection, and our code check manager will appear. And all I have to do is to click on the button with the European code, select the joint and the connected members. So it has beads, okay. And the joint will be exported. I will merge the members 5 and 17 into one and click on Connection Design. It takes a little bit, but it's already here on the second screen, so I have to take it here. So you can see we have here all the loads from FEM, but the joint is without the operations. So all I have to do is to close it. It's stored in the file from FEM, in the files from FEM. So I will close it too. And the next thing what I'll do is to go to my email software. I've got the email message from my colleague designer Reed, and I open the file. So my computer is a little bit slow, but it's okay. I've got it already. So you can see the operations are here. Everything is correctly transferred from advanced steel. And all I have to do is to click on the button Connection Import. I choose the purple. Oh, it's here, the purple file I already exported from FEM, and merge these two files into one. So, and now we have load effects and also the operations all in one joint. So I can make the calculation, but I will not do it for all the load effects. I will choose only one. So I unselect all and take only the one and make the calculation to be sure that everything is okay in this joint. So we are through, and we see something is wrong with this joint. Something is missing probably. So in this case, we go to the tab Check, and we can see there's a information singularity member 2. So we can look at the member 2. This is this one, and we can see we are missing the welds which would connect the plate and the member 2. So all we have to do is to go back to design, adding the operation cut member 2 by a plate. This one, cutting method will be surface, and the welds we will add 4 millimeters welds, and try to make the calculation again if it's okay or not. Oh, it looks good because the iteration started already. And so we are through it. Yes, and everything is okay. So we can now add all other load effects to this joint and to make the final calculation, but it would take a lot of time, so I prepared it already for you. It is you can see it here, and all these load effects are checked and everything is okay. But one thing we can do, maybe this cross beam is HEA 160, and we could try to change it to 140. So all we have to do is here to change it to 140, but we will not do it in this file. We will do it in our file I've got from colleague Wheat, and we will change it here to 140. But first, before we start the calculation again, we have to go back to our FEM and also to make the changes in this analytical model. So I will choose the members and change them here to 140. Yes, and make the calculation again. Calculate all. In the meantime, I will show you maybe some information about where to find more information about our viewers. So in the section download on our webpage, you can see the plugins where you can download them. But if you want to get more info about it, please go to the resources. And in our resource center, if you go to connection, tutorials, here is viewer, and here are the plugins for these three CAD software we have here. So for example, advanced steel, you can see all about it, how to implement it and how to use it. So I hope that the calculation is already through. And now all we have to do again is to go to our code check manager. And in this case, when we have changed the load effects and the internal forces, all we have to do with this joint is to make to synchronize, and the file will be updated with the new internal forces. So merge and connection design. So it appears probably again on my second screen. Yes, it's here on my second screen. I show it to you, and here you can see this is 140, and the forces were changed to with this update. So I'll close it and go back to our project file. And if we want to use the new forces, the new internal forces in this file, all we have to do is to clear all the load effects we imported recently and make the connection import once again. So open. So, and then we can do the final check with changed cross sections for the cross beam in the middle. But we won't do that. I will show you again the final computation of it. I have done it also before. It's here. Again, all is correctly checked, and we can see this member 4 is 140. So let's go then back to my email software, and I can reply to my colleague designer and write him, please add Weld on member 4.2 and change the cross beam to 140 and add the file. This is 140, and I send it again to my colleague Vit. And then I pass again my work to my colleague. He can take it over.
Thank you, Alexander. So the structural engineers perform the code check, and he's satisfied, and he gives me permission and some requirements what to do with this connection. He sends me requirements to add welds on member 2 and change the cross-section of one beam. Great, I will download it. I will download this file for maybe to desktop, and then I will open this project in the IDEA StatiCa viewer. Because I want to see where are the changes and where are the issues. So he talked about member 2. It seems like member 2 is this diagonal. Okay, I can zoom it in, and I can see that here is the weld, the one that I missed. Okay, change to design, sorry. And here the weld, and the thickness is 4 millimeters. Great, that's enough information for me, and the material also. And he talked about the cross beam and its cross section. Okay, here is size 140. Great, and that is enough information for me as a designer, and I can go back to my structural model to advanced steel and do some changes in my structural model. Okay, here is the weld missing. Okay, I will do my best to add it. So here in the objects, I will use a command weld point. And the hint for you, if you want to connect some entities with the welds together, you must place the weld certainly at the edge of connected element. And I will, because for me it's the easier, I will place it to the midpoint of the connected edge right here. It will be filled weld, okay, and the thickness will be 4 millimeters in an exact way like my structural engineer demands. Great. And he also demands the change of the cross section of the cross beam, which is here, so I will change it to 140. Great. And right now I did all changes what structural engineer Alex demanded from me, and I can go and I can do the or prepare the drawings, the blueprints, and proceed with my project forward. This is the end of our workflow example in today's webinar, and I'm going to pass word to my buddy Alexander again.
So thank you, Vít, and we are coming to the second part of our webinar. I will speak a little bit about our new features. Since the version 10.1, IDEA StatiCa Connection has more possibilities for joint with hollow cross sections. We would like to point out this feature, geometrically and material nonlinear analysis and local deformation check of a hollow section. All you have to do is go to Code Setup and check these two appropriate boxes. These checks are recognized by CIDECT design guides, and deformation limits are used 3% for ULS checks and 1% for SLS checks. And this geometrical and material nonlinear analysis is performed by default if the bearing member has a hollow cross-section. So when the hollow cross-section member with high slenderness is chosen, this analysis provides more accurate results than the usual analysis does. So in this HelpDesk highlight example, we can see the impact of this geometrical analysis on local deformation to the strains of the plates, which goes in hand with the distribution of the loading in the detail. So please remember, if you have hollow cross sections, don't forget to make this analysis, the geometrical nonlinear analysis. So that was all for our 2 points, and now we can look at some questions from you. Vít, do we have any?
Yes, Alexander. Thank you. Thank all attendees to placing our questions. We respond already for quite of them, and we can read some of them loud here. So Alexander, question for you. Can we use Excel's sheet to import load effects instead of the IDEA connection file like you showed in the webinar previously?
Yes, it is possible. Next to the button connection import, you can find also a button for XLS import. So if you have your load effects and internal forces in an Excel sheet, just click on this button and you can import them easily without opening a separate file from FEM software.
Thank you for your answer, Alex. And there is another one, I think really important one. Is the plugin for Advanced still free?
Yes, it was colleague Vít already mentioned it before. This plugin is completely free. You can download it here on our download page, and well, it's free.
Okay, thanks. And there was a question if the plugins are available also for other softwares, but you already showing it, so the
Yeah, we have all three softwares, main softwares. So it means Advanced Steel, Autodesk Revit, and Tekla Structures. And for example, for Advanced Steel, this plugin is available also on the Autodesk App Store. You can find it also there. And for Revit, this is the same.
And for the Tekla, you can find it on Tekla Warehouse, I think.
Tekla. Yeah. So that was about the questions. If any other questions, we will answer them separately with emails. So last but not least, fill in our short survey at the end of this webinar. If you want to see it again or share it with someone, it will be available tomorrow on our webpage and our YouTube channel. If you do not have our software yet, go to the trial or visit our resource center where you can find plenty of materials connected to our software. And what about next webinars? This one was the last one in this year, but we would be happy to see you here again in 2020. So in the meantime, we wish you a Merry Christmas and Happy New Year. Bye.
Thank you for watching, and I hope we will see each other next year. Have a nice day.